Okay, now let's start with the vectors. So we are done with the arrays. If you haven't watched the array video, please go watch it out. And then now let's start with the vectors. Now in arrays we have a limitation, and the limitation is as simple as that the size is fixed, right? Now what if we want the size to be dynamic? What if we want the size to be dynamic? So for that purpose we have vectors. So in a vector it is absolutely similar to array, no difference. The only difference is here you just need to specify the data type. That's it. You need not to specify the size of the array, right? Is similar. Let's say if I say int, and then I can say, let's say air. Okay, so now simply my vector will be initialized. Right? Now size is obviously dynamic, so we need not to specify the size of our vector. And now if let's say you want to insert some value in your array, so for inserting we have the function. So you need to write pushback. So what will happen is pushback will push the values inside your vector one by one. So basically you can insert the values one by one only. So let me write here pushback. So just give me a second, let me check my cam. Yeah, it's fine. So pushback will push the values in your vector. Let's say I want to push the value 3. So now what will happen, and this array will be of size 1, and at 0th index 3 will be pushed. Let's try pushing multiple elements. So after pushing, let's say here I push, let's say 4, let's say here 6, let's say 7, let's say 8. So now how is our vector will look like is something like this, comma 5, comma 6, comma 8. Okay, so this way our vector will look like after pushing some values. So with the help of pushback functions you will be able to push values, as many as values you want to push. Now obviously there should be a limit. It's not like you can push as many as like infinite values. Obviously there is some size constraints, and the size constraints are similar to that of array, that inside it mean it could be 10 raised to power 6 for all the like int float double. For boolean it's 10 raised to power 7, outside it's 10 raised to power 7. For int, for bool it's 10 raised to power 8. The size constraints for vector is same as array. Then for deleting an element we have the pop back. Similar to pushback we have the pop back function. This pop back function, so you can say add dot pop back. So what it will do is it will simply pop out the last element. So it should be this way. So now our this, okay, what's happening? Yeah, so now our vector will look like something like 3 comma 4 comma 5 comma 6, 8 will be popped out. So with the help of pop back function, what you can do is you can delete the last element of your vector. So after we have clear. So if you want to erase all the values, so we have the simple direct air dot erase function. So you can use air dot erase to erase all the values of your vector. Then we have all the iterators, absolutely similar, like air dot begin, air dot end. So you can use similarly, we have r end, we have r begin. So all the 4 iterators are same as that of array in our vector as well, right? So after iterators we have yeah, and we have the same as iterators also. Even if you want to specify the size of your array, let's say, let me write here vector, and then let's say int, and let me declare a vector, let's say vec1. So what you can do is you can specify the size, and you can also specify a value. Let's say if I specify here 10, now what will happen, a vector will be created with 10 at all the indexes. Okay, for 10 at all the indexes. Similarly, let's say you want to copy all the elements of this vector 1 inside vector 2. So let's declare another vector, let's say vec2, oh sorry, int here, and let's say vec2. And what we can do is I can say vec1 dot begin. It means from wherever it will point to the first index, that is 10. And then you can say vec1 dot end. Okay, and -1, because and will point to the one extra memory, so you can say and -1. Or what you can say is, let me copy paste this thing. Let's say you don't want to copy all the elements, okay, so instead of this thing, what I can say is, I can say let's say begin plus 2, begin plus 2. That will also do our job. Okay, so let's say if you want to copy some elements from this vector 1 inside vector 2, you can copy this way. Let's say if you want to completely copy this vector 1, then also you can completely copy this vector 1. So I guess that is all about vectors. Like, it's all similar, guys. Like, it's absolutely similar to arrays. Okay, nothing new. Like, there is just pushback and popback. We have the erase to erase all the elements. The only difference is the size of vector increases dynamically, and in array the size is fixed. Other than that, vector is all similar to array. And there is some quite easy functions, like there is add dot front. So this front will give you the first element. Similarly, we have add back, it will give you the last element. And we have add dot at, and you can specify the index, so it will give you the element at the second index. And then of course add dot size or vec1 dot size, the size function is similar. So these are like common basic functions. Those will be like you will find in most of the containers, like front, back, add, size. Okay, let's then start with something called as set, right? So let's start with sets. So what are sets? So simply, if you, let's say, want to store unique values, so we have these sets. Again, in container, you just simply type int. Let's say you specify the type, then st. Let's initialize it with some values, right? And our st is initialized, and let's say you can directly say something like for auto I, let's say I. It's kind of similar to for each loop. You can say like sorry, not auto I, so you can say auto I and then st. So what will happen is all the values of st will be passed one by one to I. Then you can see out this I uh, this way. Let's try running the code, and let me just comment this all of this code. Just give me a second. Yeah, so let me just comment this much code. Yeah, so yeah, so you can see it is printing 1 2 3. So it is removing basically all the duplicates. It is removing basically all the duplicates, right? So there is a property, it will sort it in ascending order, and also it will remove all the duplicates. Okay, so that is what the property of a set is. Then we have some more functions, like we have st dot erase. We have a erase function, so you can erase any value. Let's say you can say 2. So now what will happen, 2 will be erased. Or what you can say, st dot begin. So or even you can pass a iterator, it will erase the first value. Or you can say st, okay, here it should be erase. And or you can say st dot erase, st dot begin. And you can, after comma, you can provide how many values. Let's say I want to say st dot begin, let's say +2. So it will start from st dot begin, and it will go till the next two values. And let me provide some more values. Yeah, so what will happen is, it will start from the first iterator, the first value, basically the 1, and then it will delete till the next two values. And here in this case, it will delete all the instances of 2. Here it will delete all the instances of this thing. Next, in set we have this find. Okay, find will obviously return an iterator, so you need to write auto I. So if you say, let's say st dot find, let's say you want to find 2, so it will return an iterator pointing to the pointing to 2. Okay, pointing to the value 2. Wherever your 2 is, it will point to that value. Again, all those functions like dot size, dot add, front, back, all are similar. I don't think so we need to like keep repeating them again and again. And also if you, let's say, don't want to initialize values, then we have the st dot insert as well. So you can say st dot insert any value. So with the help of insert function you can insert values, right? So let me comment these things out. Then after set we have an unordered set. Unordered set. So in unordered set, let's see what will happen. Let me show you printing. So it will take any order. There will be no order, so it will take any order, whether ascending or descending. Rest of the functions will behave the same way. Rest of the functions will behave same way. Then we have something called as multi-set. We have something called as multi-set. So in multi-set, what will happen is it will even save the duplicates as well. It will save the duplicates as well, and in the ascending order, it will be in the ascending order, and also it will save all the duplicates. Okay. So I guess that and the all the iterators like the dot begin dot and r begin, all of them will remain same. So with that part, I guess we are done with sets as well. Then after set we have something called as a map. So let me tell you something about map first, and also we have dot erase as well. So let's say if you say st dot erase, let's say 3, so it will erase all the instances of 3. It will erase all the instances of 3 in case of a multi-set, if it's a multi-set, right? Let me comment this and let's move forward with the map, right? So now you may ask what a map is. So let me tell you what a map is. So basically, let's say if you have an array, let's say if you have an array, and let's say you have some values. Okay, so this sort of a array you are having. Let's say what you want to do is you want to find frequency of each and every number present within this array. Let's say 1 is 3 times, right? 2 is twice, 3 is twice, 4 is once, right? So let's say you want to find the frequency, right? So one method for finding the frequency is that you initialize one frequency array and initialize it to 0. Like in frequency array, you initialize it all the indexes to 0, and then you iterate through your main array, and every time you find a particular element, so whatever, like if it's you found 1, then go to index 1. Let's say we have this frequency array, let's say 0 comma 0 comma 0 comma 0 comma 0, right? So 0 1 2 3 4 5, these are the indexes, and 0 1 2 3 4 5 6 7, these are the indexes. So here also 6 and 7, right? So now what will happen is, let's say we found a 1, so we go to index 1 and we will make this value or this count as 1. Then again we found a 1, we will make this as 2. Then we found a 2, we will make this as 1. Then we found a 3, we make this as 1. We found a 1, we make this as 3. So this way our frequency array will be prepared. This way our frequency array will be prepared. But given the case that all the values present within the array should be lesser than n, all the values should be lesser than n, we cannot create this frequency array. Let's say if you have elements like this, let's say like something like this, because let's say if you have 10 raised to power 9 as an element in your array, so obviously we know the maximum size we can declare is up to 10 raised to power 7 or 10 raised to power 8, so we cannot handle 10 raised to power 9 in frequency arrays. So always go for the constraints of your question. So the first preference should be this frequency array, because this is the most fastest way, right, for this hashing purpose or for this mapping purpose. But if you have such constraints where you cannot create a frequency array, in that case what we will do is we will create maps. So maps are nothing but simply key value pairs. We have the key value pairs. We have a key, and this key could be of any data type, and similarly we have a value, and this value can also be of any data type. This value can be of also any data type. So let's create map with the help of C++stl function. So we will start with maps, and for creating a map, simply you need to use map, and you need to specify both the data types. Let's say I want the key to be of type string, I want the value to be of type integer. Then let me create a map. Let's say let me name it as mp, right? So this way you can create a map. Then if let's say let's add some values. Let's say let me add here, let's say some values. Let's say I got a value 6. Then let's say um, let me create some random keys, and let's give some let me give it some random values, and let me copy paste this thing. Okay, so obviously the keys will be unique, the keys will be unique. So let me comment this thing: keys will be unique and sorted. So the values will be saved in a sorted manner according to the keys, not according to the values. So values will be saved in a sorted manner, sorted according to the keys, and all the keys will be unique. If you like basically repeat a key, then the value will be updated, but the key will remain only one in a normal set, right? So I'm just creating this set. Then again, let's say if you want to iterate through this, let me write here auto I mp, and let's say I want so we have two things. We have in any container like this map, or or any type of map, ordered map, multi-map, whatever the kind of map is. So the data is saved in a form of pairs. Okay, so let me tell you how. So let's say a map is created. Inside map we have somewhat we call it as pairs. Okay, so and in a pair we have two values, and we can access those two values with the help of the function dot first and dot second. So here let's say if I want to I'm iterating through my map, then what I can see out is I can say I dot first. So what will happen is it will print all the keys. Okay, let's say if you want to print all the keys, so let's see. So it will print all the keys here. So okay, it should not be a semicolon, it should be a colon. So let's see. So it will print all of our keys. So these keys you can see, and these are in the ascending order. So also let me make it as, let's say A, let's B, this thing C, this D, this E, so that you can see all of these are sorted according to the keys, and as well as all the key only unique keys are only stored here. Okay, so let's say similarly if you want to get all the values, you can use the dot second function here instead of the dot first function. Then we have this dot erase function. This dot erase function is absolutely similar to that of the this set and all. So let's say if you want to erase any value, just let me make it as mp. No difference, you can specify any key, the particular key you want to delete. You can or even say mp dot begin, the first key will be deleted. Or even let's say you can say my first key is, let's say arog, so this key will be deleted. So my battery is running low, just give me a second. Yeah, let's continue. So we have similarly the dot find function. If you want to find a particular key value, we have the same dot find function. Also we have dot empty function. This will tell you if your map is empty or not. It will return true if it's not empty. It will return true if it's empty. It will return false if it's not an empty map. Okay, so we have the similar all of these similar functions. Then we have something called as let's say a multi-map and an unordered map. So now what will happen in a multi-map and unordered map? Obviously, as the name suggests, let me make it as unordered map. So obviously it will be unordered. There will be no sorting according to the keys. Obviously the keys will be unique, but there will be no sorting. Okay, so the keys will be randomly saved. Okay, so there will be no sorting in an unordered map. Rest of the functions will work the same way. Then we have what we call it as a multi-map. So let's talk about a multi-map. So for multi-map you will simply say multi, right? So this way you can declare a multi-map. For inserting values inside a multi-map, we have the dot insert function, and inside the dot insert function, obviously we need to insert the pairs, right? have the insert function. So I'll basically write here mp.insert, and let's say we will be inserting a pair. So we have this data type pair we talked about earlier as well. So let's say in pair I want two values, one of data type string, one of data type integer. So and let's say the first value I want to provide is a random value and second is an integer. So this way, and then again I'm just, if you just iterate through the array, it will print all the values. So like you can see it is printing this ASD. So this is how a multi-map works. And in a multi-map, what will happen is you can save duplicate keys as well. Okay, so if you insert one more key with this same ASD, this same thing, and let's say with a different value, then it will save both the values. Okay, it will save both the values. That is a good thing about this multi-map. Let's say if you want to save the duplicate keys as well, then you can for that purpose use the multi-map. The rest of the functions, I guess, work in a similar manner. So no sorting, no there will be no sorting, no unique keys, everything like it will be a simple map without sorting, without any unique key. So I guess that is all about the containers. So I guess it was a nice journey, like going through all the containers all over again. Yeah, so with that this lecture will end, and please stay tuned for the next upcoming lectures for all the competitive programming stuff. Okay, thanks.